The cool thing about integration by parts is you can do it over and over again, and it simplifies your integral as you do it, hopefully, if you've made the correct choices of u and dv. Here, if we're trying to integrate the product of x squared and e to the x, you know that no matter what you do to e to the x, if you differentiate it or integrate it, it's going to stay e to the x. So that's not going to get any more complicated. If you think about differentiating or integrating x squared, if you integrate it, it becomes something x cubed, right? It gets worse. It becomes more complicated. So if we choose to differentiate it, it will drop down in power and become more simple. So if we perform integration by parts here, I'm going to choose to differentiate the x squared function and anti-differentiate the exponential. So du is going to be 2x dx. V is going to be e to the x, which means that the integral x squared e to the x can be written as u times v minus integral v du. So notice we started with x squared times e to the x, and now we just have 2x times e to the x. So our integral got easier. But this lends itself to another integration by parts. So let's do it again. We will choose to differentiate the 2x because it will become more simple, and we will integrate the e to the x. So this integral, x squared e to the x dx, is written as x squared e to the x, and then minus the integral. And we are going to replace that integral with the integration by parts formula, a uv minus v du. So open up a big set of brackets, and uv minus integral v du. And uv minus v du replaces that integral because of this application by integration by parts. All right, and here I think we can recover a final answer. X squared e to the x minus 2x e to the x, and it ends up being plus, I can pull this 2 out of the integral, 2 integral e to the x dx, and that last integral is finally a simple enough integral that we can solve it. And where did I first integrate? This first application of integration by parts has a plus c. Cool. So we found an antiderivative of a complicated product by just always choosing to differentiate the polynomial because it gets simpler and simpler until we finally have an integral that we can solve.